this episode, we focus on something that sounds like routine maintenance, but can quietly become the biggest source of risk in an AI program: retraining and updates. Artificial intelligence, AI, systems are rarely static because teams improve them, vendors change them, data shifts around them, and the business asks them to do more over time. That constant change can be a strength when it is disciplined, but it becomes dangerous when updates happen faster than the organization can understand their impact. Many beginners assume an update is automatically an improvement, yet an update can also introduce new hallucinations, weaken safety filters, change bias patterns, or expose data in new ways. The goal today is to make two protective ideas feel practical and connected: governance gates and regression testing. Governance gates are the decision points that determine whether an update is allowed to move forward, and regression testing, RT, is the repeatable evidence that the update did not break important safety and performance expectations. When you can explain these ideas clearly, you can also explain how responsible organizations improve AI systems without accidentally shipping new harm. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good way to ground this topic is to remember that retraining and updating are not only technical actions, but also changes to the promises an organization makes to users. When a system is deployed, it creates expectations about what it will do, how reliable it will be, and what it will not do, even if users never read a policy. An update changes that reality, sometimes in small ways and sometimes in surprising ways, because AI behavior can shift with tiny adjustments in data, configuration, or prompting. This is why updates must be treated as risk events, not as casual tweaks, especially when the system touches sensitive information or influences decisions. A beginner misconception is that if you can roll back, you can update freely, but rollbacks are not magic, and harm can occur before you notice a problem. Another misconception is that only model weight changes count as updates, when in reality changes to retrieval sources, context settings, safety filters, and user interface cues can also change outcomes significantly. Controlling retraining and updates means controlling the full behavior package, not just a file called model. When you build that mindset, governance gates and RT start to feel like basic safety rules rather than bureaucratic hurdles. Governance gates are the first protective idea, and a simple way to understand them is as intentional pauses where the organization asks, should we allow this change to affect real users? A gate is not a meeting for the sake of a meeting. It is a decision checkpoint tied to evidence and accountability. The gate can be early, such as before new data sources are approved for training, or later, such as before a new model version is deployed, but the key is that gates are pre-planned, not invented during crisis. A gate also has clear owners, meaning specific roles are authorized to approve or reject based on defined criteria. Beginners often assume gates slow everything down, but a well-designed gate actually speeds up safe change because it creates predictable requirements and prevents last-minute surprises. Without gates, teams debate every change from scratch, and debates become emotional and inconsistent. With gates, teams know what evidence is required, what tests must pass, and what risks are unacceptable for the intended use. Gates also protect people in the organization because they prevent individuals from being forced to make risky decisions alone under pressure. When gates are clear, responsibility is shared and defensible. A mature gating approach also recognizes that not all updates deserve the same level of scrutiny, because risk is not uniform. Some updates are low impact, like minor tuning that affects formatting, while others are high impact, like expanding the system into new decision domains or connecting new sensitive data sources. Governance gates should therefore be proportional, meaning higher impact changes require stronger evidence and broader review. This is not about punishing ambition. It is about matching oversight to consequences. A beginner misunderstanding is that proportionality means you can skip gates for small changes, but the better interpretation is that every change passes a gate, and the gate requirements are lighter or heavier depending on risk. Proportionality also reduces fatigue, because if every update requires a heavyweight approval, people will eventually treat gates as obstacles and try to bypass them. A good design keeps gates meaningful and achievable, so compliance feels like the normal workflow rather than the slow path. Another key element is documenting gate decisions, because later, when someone asks why a change was allowed, you need a clear story tied to evidence. When gates are predictable and documented, governance becomes a practical operating system for safe evolution. Now let's connect governance gates to the idea of regression, because governance without evidence becomes policy theater. RT is the practice of rerunning important tests after a change to make sure the change did not break what previously worked. Beginners sometimes think regression is only about performance, like accuracy, but in AI risk management, regression also includes safety behavior, privacy behavior, and misuse resistance. If the system previously refused unsafe requests, you must confirm it still refuses. If it previously avoided leaking sensitive information, you must confirm it still avoids leakage. If it previously handled certain user groups fairly, you must confirm it still does so. A key beginner concept is that you are not testing from scratch every time. You are protecting against backsliding. Systems drift not only because the world changes, but also because updates can accidentally weaken guardrails, especially when teams optimize for helpfulness and speed. RT creates continuity because it preserves known safe behavior across evolution. It also turns quality from a feeling into a measurable claim, which makes governance gates defensible. When you can say this update passed RT against our critical safety cases, you are making a stronger statement than we think it looks fine. The most important part of RT is deciding what belongs in the regression set, because you cannot test everything, and testing irrelevant cases creates false comfort. A strong regression set is built from the things that matter most for the use case, and from the failures you most want to prevent. That includes known high-risk prompts that previously caused hallucinations, known sensitive contexts where privacy leakage risk is high, known abuse patterns that previously bypassed filters, and known edge cases where the model previously struggled. It also includes representative normal use cases, because a model that is safe but useless is still a problem. Beginners often assume the regression set should be generic, but generic tests miss the specific risks created by your organization's workflows, data, and user expectations. Another important practice is to include real incident learnings, because every incident reveals a scenario you did not anticipate, and that scenario should become part of what you never want to repeat. Over time, a regression set becomes a memory of your program's lessons, which is valuable because organizations forget faster than they expect. When your RT suite grows in response to real experience, it becomes harder for updates to reintroduce old harm. Regression evidence is also only as trustworthy as the ground truth and the measurement approach, which is where beginners often feel unsure. For some tests, ground truth is obvious, like a refusal should happen for a clearly unsafe request, but for other tests, quality is more nuanced, such as whether a summary is faithful or whether a recommendation is safe in context. That nuance is not a reason to avoid testing. It is a reason to define evaluation criteria carefully. A mature program uses consistent criteria so that results are comparable across versions, and it records those criteria so reviewers know what passed means. Another important concept is repeatability, because if your test results fluctuate wildly from run to run, you cannot confidently attribute changes to the update. Repeatability might involve controlling the test environment, controlling the prompts, and controlling how results are judged. This connects back to reproducibility and versioning, because regression results must be tied to a specific version of the model, configuration, and data. Beginners should remember that the goal of RT is not perfection. It is early detection of meaningful regressions that could harm users. When evaluation is consistent and tied to version records, it becomes a practical safety signal rather than a scientific debate. Governance gates and RT also connect strongly to change management discipline, because updates often bundle multiple changes together, which makes regressions harder to diagnose. If you update the model, change the prompt template, add a new data source, and modify a safety filter in a single release, and the system becomes unsafe, you will struggle to identify which change caused the problem. A beginner-friendly lesson is that smaller, controlled changes are easier to validate and safer to roll back. That does not mean you never make big updates, but it means you treat big updates as higher-risk events with stronger gating and more extensive regression coverage. Another useful practice is to define the intended improvement clearly, because if the goal is vague, any change can be justified after the fact. Clear goals let you test whether the update achieved the improvement without unacceptable trade-offs. For example, if the goal is to reduce hallucinations, you should be able to show hallucination tests improved without safety refusals weakening or privacy leakage increasing. When goals, tests, and gate criteria align, the update process becomes rational rather than political. That alignment is what keeps programs stable under pressure. It is also important to understand that retraining introduces unique risks compared to other updates, because retraining changes what the model has learned, not just how it is configured. Retraining can incorporate new data that contains bias, new sensitive content, or new manipulation attempts, and once that influence enters the model, it can be difficult to untangle. This is why retraining governance gates often begin earlier than deployment gates, at the point where new data sources and new labeling practices are approved. Beginners sometimes assume the risk begins when the model is released, but for retraining, risk begins when the learning material is chosen. If you approve a dataset that includes sensitive customer content without clear purpose limits, you may create privacy exposure before you even run the training. If you approve a dataset that is skewed, you may create fairness regressions that show up later as uneven performance. If you approve data from untrusted sources, you may increase poisoning risk, which can create targeted unsafe behavior. Retraining control, therefore, includes data integrity controls, provenance documentation, and clear approvals for what data is allowed to shape the model. When those controls are paired with RT, you can detect whether the retrained model behaves within acceptable boundaries. Updates from vendors add another layer of complexity because your organization may not control what changed internally, yet you still own the outcome for your users. Vendor updates can alter model behavior, safety filters, context handling, or underlying training data influence, and those changes can be subtle. A beginner misconception is that vendor-provided systems are always safer because experts built them, but vendor updates can still introduce regressions relative to your use case. This is why governance gates should include a rule that vendor updates are treated like any other update. They require regression evidence before broad rollout. In practice, that means you maintain your own test suite and you rerun it when the vendor changes the service, even if the vendor provides their own claims. It also means you pay attention to change notices and to what the vendor considers a minor update, because minor updates can still affect your risk profile. Another important idea is to maintain rollback or fallback options if the vendor update causes harm, such as restricting use temporarily or switching to a safer capability mode while issues are investigated. When vendor updates are controlled through gates and RT, you convert dependency risk into managed dependency risk. A major reason programs struggle with retraining governance is that updates are often driven by business urgency, and urgency pressures teams to weaken gates. When a deadline approaches, people start asking for exceptions, and exceptions become the fastest path to drift in your governance posture. This is where the idea of accountability under pressure becomes real, because someone must be willing to say the gate criteria are not optional when safety and privacy are at stake. The healthiest programs do not rely on heroic refusal. They design gates that are efficient and predictable, so meeting them is part of normal planning. That means teams build time for regression and review into the release schedule rather than treating it as a last-minute add-on. It also means leaders understand that a faster unsafe release is not truly faster if it causes incidents, rollbacks, and lost trust. Beginners should remember that the cost of an incident is not only technical recovery. It includes reputational damage, user distrust, and sometimes legal obligations. Governance gates exist to prevent the organization from gambling with those costs. When pressure rises, gates should become more important, not less, because pressure is exactly when mistakes happen. Controlling retraining and updates also requires clear decision rights, because ambiguity about who can approve changes creates both delay and risk. If nobody knows who owns approval, updates either stall or slip through informally. If too many people can approve, approvals become inconsistent and fragile. A mature approach defines roles such as who can propose changes, who can run training jobs, who can review data provenance, who can approve deployment, and who can authorize exceptions during incidents. This role clarity supports speed because people do not waste time negotiating authority in the middle of an urgent situation. It also supports evidence because approvals are tied to names and rationales rather than to vague group consensus. Beginners sometimes assume governance is a committee, but governance can be structured so that decisions are made quickly by the right owners with the right evidence. Clear roles also support auditing, because auditors want to see that high-impact changes were approved intentionally and that the program can prove consistent control. When decision rights are defined, the update process becomes a predictable pipeline rather than a series of improvisations. That predictability is a safety feature in its own right. Finally, it helps to connect all of this back to user trust, because the practical reason to control updates is that users experience the system as a stable tool. If outputs suddenly change tone, suddenly become less reliable, or suddenly reveal information they should not, users do not interpret that as a technical regression. They interpret it as the tool becoming untrustworthy. Once trust is broken, users either abandon the tool or use it in secret in uncontrolled ways, and both outcomes increase risk. Governance gates and RT protect trust by ensuring updates are deliberate, tested, and consistent with the system's safety promises. They also protect internal teams by reducing fire drills, because fewer regressions means fewer emergency containment events. Beginners should recognize that a disciplined update process is not about avoiding change. It is about enabling safe change repeatedly. The ideal is a program that can improve models confidently, because it has gates that ensure accountability and tests that ensure continuity. When you can update safely, you can respond to drift, new threats, and new business needs without turning each update into a gamble. That is how an AI system remains useful and responsible over its lifespan. As we close, controlling retraining and updates is about ensuring that improvement does not come at the cost of safety, privacy, fairness, or trust. Governance gates create intentional decision points where updates are reviewed against clear criteria and owned by accountable roles, and proportional gates prevent both overreaction and bypass fatigue. RT provides the evidence that a proposed change did not break critical behaviors, including performance expectations, refusal behavior, privacy protections, and resilience against misuse. When retraining is involved, governance must begin with training data integrity, provenance, and labeling discipline, because what the model learns from shapes everything downstream. Vendor updates must be treated as real updates that require your own validation, because your organization owns the outcomes for your users. Under pressure, gates and regression evidence become even more important, because urgency is when shortcuts turn into incidents. For brand new learners, the key takeaway is simple. AI systems can only be improved responsibly when change is controlled, and change is controlled when governance gates and regression testing work together to keep every update within safe, proven boundaries.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.